Okay, so very good. Now, what I would say when we look at the published solution here, pretty good, pretty good. It looks like to me there's a couple things that maybe we could do a little better than they did, honestly. So for one thing, let's talk about how do we get to the substitution equation. So we're starting here, aren't we? We're going to isolate the y. So if what can we do? Subtract 7x from either side, so I get minus y equals negative 7x plus 34. But I need to isolate y, not negative y. So what's the last step? Okay, I'm going to show that as a product, as multiplying instead of dividing. It's easier to do that, right? So we're just going to distribute a negative all the way through everything. And then what do I get? It's going to make that a positive y. This becomes 7x. That becomes negative 34. And then always put a box around your substitution equation because you're going to come back to it, right? It really does make it easier. And so then you were good from there. We make the substitution where we're going to plug that y into the other equation, right? And so we get 2x plus 3 times with a quantity, 7x minus 34. We distribute the 3, collect like terms, divide by 23, and we get x equals 4. Here's where it would be a little bit easier to be able to just go right back. Once we get this part of our solution, we just go right back to the box equation, right? The substitution equation. And what do we get? Y equals 7 times, we're going to replace the x with a 4 in parentheses, minus 34, so y equals 28, minus 34, so y equals negative 6. And so there's our solution, right? Okay? All right, so what about this, though? Here's what we're moving on to today. Here's another linear system. This one, substitution isn't going to work well here, is it? Right? What could we do? We could, in the bottom equation, maybe, I guess the easiest thing to solve for maybe would be x. It's got the smallest coefficient, but it's still really bad. If I solve for x in the bottom equation, I've got to divide everything through by 2, and that's where things go south. Right? Then we end up with x by itself equals negative over positive is negative 7/2 y, positive over positive is positive 3/2. That's a terrible substitution equation, right? We don't want to go there. Okay? So I'd have to plug that into the top equation, and that would be bad. I have to multiply a 5 through everything, and then when I solve for y, I'm dealing with a bunch of fractions the whole time. Right? So we're going to do something different. We're going to move on to Plan B. Plan B is another technique for solving a linear system called elimination. And this makes things a lot easier. So on your handout, you got this. Everyone should have this handout, right? Solved by elimination. We're going to make a change right away. So here are the instructions at the top of your notes. We're going to make a change to this, and we're going to do this instead. This is a better way to do it. Okay? So we're going to change the instructions a little bit. On line 2, cross out the same coefficient and write in opposite coefficients. And on line 3, cross out subtract. Okay? So it's kind of a 5-step process, and that sounds like a lot, but it's really not. They go together so logically that you'll remember. Once we go through this once or twice, you'll be good. Okay? And then I'm having practice with a little board work at the end to practice this. So in order to introduce these steps, the 5 steps, let's just do a problem. And we'll talk about each one as we go. Okay, so step 1, line up the equations. Now, what does that mean? Line up the equations means that all of the terms have to line up vertically. Okay, so it means that we want the equations to be in standard form, although it doesn't actually have to be perfect standard form. We don't really want any fractions in there, but we don't really care if a is negative or positive here. It doesn't really matter. We just need to have the x term first, and then the y term, and then the number. So they line up vertically like that. Okay? Once we line up the equations, then we got to ask ourselves, okay, this is where we got to be strategic about it. We're going to multiply one or both equations by a number or maybe numbers, maybe both by numbers, so that after we do that, we'll have opposite coefficients for one of the two variables, either the x or the y. And we want to always ask ourselves, which one's going to be easier to get rid of? In which case could we multiply by fewer numbers, and could the numbers be smaller? Okay? In this case, we're going to get rid of the x's, and all we'd have to do to get opposite coefficients, what are the coefficients right now? 1 and 1, right? But what could I multiply the bottom equation by to get opposite coefficients? -1, right? All I've got to do is distribute a -1 through the bottom equation, and then I'd get opposite coefficients of x, okay? If I were going to do the y's, I'd maybe multiply the bottom through by what? If I want opposite coefficients for the y's. Right now, for the y's, I've got a 7, it's my coefficient on the top, and a -1 on the bottom. What could I multiply the bottom by? 7. Yeah, if I multiply the bottom by 7, then I'd have +7y and -7y. Get opposite coefficients, right? One's positive and one's negative. You get the idea? But multiplying by 7, that's a bigger number, so we're not going to do that. We'll multiply by -1 instead. So we can just do this, right? We could just go down here and distribute through a -1 in the bottom equation, and then what's going to happen? Well, the top one stays the same. The bottom one, if I distribute a negative through, what's it going to become?
-x plus y.
-x plus y equals +7, right? When I distribute the negative through the whole thing, it just changes all the signs. And then, so there's step 2, right? Step 2 is we multiplied one or both equations by the same number, resulting in a variable with opposite coefficients. In this case, we only had to multiply the bottom equation by -1. Step 3 is we're going to add the equations to eliminate the variable, okay? So when we add these up, look what happens. The x's go away. That's why we call this elimination, because now we just eliminated x from the mix, right? And we end up with what? What's 7y plus y? 8y. 17 plus 7, 24. How many variables are we dealing with? 4. It's easy. What's the only thing I have to do to get the y by itself? Divide by 8, and what's 24 divided by 8? 3. Okay? So y equals 3. Now what? Plug it in. We're going to go back to the original system and pick the easiest one to plug it into, top or bottom? Bottom, yeah. So if we plug 3 into the bottom equation is just x minus y equals -7, right? So we're just going to get x minus, I'll open up an empty quantity to dump the y value in, and it equals -7. Well, what y value am I dumping in? 3. Okay, now there's only one thing left to do to solve for x. What's that? Add 3. And what do I get? Yeah. Okay, and then I'll write that as an ordered pair. -4, 3. Okay, you get the idea? Okay, let's try another one. How about down here? Now, we always want to take a little time to think about this. Which variable is going to be easier to eliminate here, the x or the y? I'm hearing x. Okay, what's an argument for x? Okay, the coefficient's 1. Okay. Now we're thinking in terms of what do I have to multiply by here? Lower numbers. Okay, now if I want to eliminate the x's, I could multiply the bottom equation by what number? -4. Right. If I wanted to eliminate the y's, that'd be harder. I'd have to get opposite coefficients, so I'd have to multiply the top by like 5 and the bottom by 9. Right? So I could get a -45y and a +45y. But that's 2 strikes against that method, because I've got to multiply both equations instead of one, and I got to multiply by bigger numbers. So clearly it's a lot easier to get rid of the x here, isn't it? Right. Now here's another way of showing it. This is the way I prefer, but you can take your pick. Rather than putting it in brackets, the second equation in brackets, and putting a -4 out front, here's another way to show that I've used in the past that I kind of like. You're just going to draw an arrow, and if I draw I'm not gonna change the top equation, so I just draw a plain old arrow, which means we're just gonna rewrite the top equation as 4x minus 9y equals negative 42. You told me we're gonna multiply the bottom equation by what? Negative 4. Okay, so we're just gonna put a bubble in the bottom arrow, and the number that's in the bubble is what we're gonna distribute through both sides. Yes, sir?
So on the one above, right,
Mhm.
it was positive 7 over negative y, and here it's 4x over positive x. But-
4x, right.
But on the bottom, we multiply everything through by negative 4, but on the top, we multiply it through negative 1. But why did we do it, like, we only multiplied the bottom numbers on negative 1. So we did, or on number 1. Does that make any sense? Like,
That's all we're gonna do here too.
but,
The top one, we left alone.
but why negative 4?
So, okay, so the
And why not
x's will be
negatives?
opposites.
Oh, just the x's?
Yeah, that's all we care about. We can only eliminate one variable at a time. Now, if they both go away, then something weird is happening. Then maybe it's a no solution, or, or infinitely many solutions, right?
But my question is like, why not multiply by negative 7 on the top, but multiply by negative 4 on the bottom? You see what I mean?
On,
Like-
which one are we talking about?
So on number 1, the opposite variable of negative y is 7y, like that's the one above it, is
Mhm.
7y. But instead we multiply by negative 1.
Instead of multiplying by positive 7.
Yes.
Right. The only reason we didn't multiply by positive 7 is 7 is bigger than 1.
Okay.
If I multiply by 7, I gotta do 7 times 17, which is kinda tough.
Okay.
It would've worked, but we just always wanna choose the easiest one we can. Right, smaller numbers, right. So now in the bottom, when I distribute a negative 4 through, we're gonna get what?
4x.
Well,
Well, negative
negative 4x, which is what we wanted, right? Negative 4 times positive 5 is gonna give us negative 20y, right? So I got negative times positive. And then my constant's gonna be negative 16. Good. Okay, and when I add these up, look, the x's are eliminated. Now, we've eliminated the x both times, just accidentally, but is there anything special about eliminating the x? No, we could easily eliminate the y if that's easier to do. It doesn't make any difference the order in which you find these variables, right? To solve for the variables. When we add these up then, what's negative 9y plus negative 20y?
29.
Negative 29y. Negative 42 plus negative 16? Negative 58. And then what do I have to do to
Right.
isolate y? Divide everything by negative 29, right? And then what's that give us? I'm gonna get that's gonna give us y equals negative over negative is positive, and I get a 2. Good. The only reason I like this method better is now when I go back to the original system, it's not messy. It's easy to see. It's easier to plug back into the original system. So which equation do we want to plug into? Bottom one. Good. So we'll go plug in for that y value. And so I get x plus 5 times the y value we're substituting equals 4. Well, the y value we're substituting is 2. And so, what am I gonna get? X, so what's x? Negative 6. Right, and so we end up then with the ordered pair. X is negative 6, y is 2. Yes, ma'am. Yeah. Okay, let's look at one more together. I'm going to turn you loose and let you practice this. So now this one's maybe slightly tougher. How come?
No isolated. Like,
Okay, it's a little bit tougher to eliminate something in this case, right? Now, it's not like there's a huge advantage, but probably it's a little bit easier to eliminate which variable here.
Why?
2x.
Why do you say why?
Because you could just multiply the top by 2 and the bottom by 5.
You mean the x's, you mean?
Yeah, the x's.
Get rid of the x's? Okay, yeah, the x's might be slightly easier. right? If I wanna get rid of the y's, I'd have to multiply the top by like 7 and the bottom by what? Well, -3, right? If I wanna get rid of the x's, I can multiply the top by 2 and the bottom by -5, exactly. Okay, so let's do that. So then, we're gonna multiply the top through, and I would do these one at a time, so you can kind of see the result, just to verify that you're doing it right. So on the top, you said we're gonna multiply through by +2. What's that gonna give us if I distributed 2 all the way through the equation? 10x plus 6y. Good. And so then on the bottom, once again, we need to get a -10x, right? Because we're getting rid of the x's. So we need to multiply by -5. There we go. Okay. And if I distribute a -5 all the way through, what am I going to get?
-10x minus 35.
Good. Okay. And if I add those up, the x's cancel, right? Yeah, you bet. X's cancel. Now, what about this one? Let's, I know this is like really kind of stuff you did ages and ages ago, but what's our rule here? If I'm adding up, let's get phones away, please. If I'm adding up, phones should be away. Away. If I'm adding up opposite numbers, so I have a +6 plus a -35y, same thing as 6 minus 35. Remember the rule, all you're gonna do is subtract the smaller number from the bigger number and keep the sign of the bigger number, right? So what's 35 minus 6? 29. I'm gonna make it negative because the bigger number is the negative, right? So I get a negative (29y) equals, so what's y then? 1. Good. And where am I gonna plug it? Bottom one. Doesn't make much difference this time, does it? We'll go in the bottom. So I get 2x plus 7 times my substitution value for y equals 3. And that value is a 1, right? So we end up with 2x plus 7 equals 3. What are the 2 steps in order to get the x by itself? Okay, good. So we're going to subtract 7 first. So the 7's cancel. That's good. And then we get 2x equals
-4.
4. There we go. -4. And then you said what next? And so we get x equals
-2.
-2. Okay, good. And then that means that we get the ordered pair -2, 1, right? Okay. Now, how would we check that if we wanted to? Plug them back into both equations, right? It has to be a solution of the system. Remember from Friday, it has to satisfy all the equations in the system. Got to make them all true. Okay? Good. All right. So more board work. Yeah, we got time. We'll probably only get through one.